Geologist Jim Miller will take us on a deep dive into the ancient lava flows of Sugarloaf Point.
So this is the top of the lava flow. Notice how brick red it is. Basalt has about 10% of it is composed of iron. And so when that iron is exposed to oxygen, it oxidizes and creates, it basically rusts. And so that is what leads to this brick red color. And it's a nice marker as you're walking through the lava flows. You'll see that brick red horizon that tells you, this was the exposed upper surface of the lava flow.
Jim explains that other details in Sugarloaf's lava rocks help us recognize different flows and how they were formed. Fresh lava emerges from deep in the earth to spread out on top of older flows. The wrinkled surface of this flow is known by the Hawaiian name Pahoehoe. This Pahoehoe flow is covering an older flow with a chunky texture called A'a. The two types of lava are found worldwide and caused by differences in how fast the lava was flowing. You can't help but recognize the Pahoehoe texture on recently hardened lava. And looking a little rusty at 1 billion years old, it can also be found today at Sugarloaf Point. But there's more. And to learn about it, we're going inside of a lava flow. The lava is under less pressure when it reaches the surface. Gas bubbles, water vapor, and carbon dioxide begin to form and rise vertically. But when the bubbles reach the top of the flow, they get trapped because the lava thickens as it cools from contact with the air above. They leave small holes in the rock that are called amigules. The bottom of the flow cools from contact with the rock beneath it. Here, the rising bubbles leave behind open tubes called pipamigules. The bubbles always rise vertically, so the angle of pipamigules found 1 billion years later at Sugarloaf indicates which way was up when the bubbles were formed. And if the lava was still moving as the bubbles rose, pipamigules might bend to show the direction of that movement. Sometimes bubbles come together as they rise, creating pipamigules shaped like the letter Y turned upside down. You won't find amigules in the middle of the flow, which stays super hot longer than the top and bottom. This lava, which hardens into what's called massive basalt, resists erosion from water and ice better than the top and bottom of each flow. One more fun fact. Beautiful semi-precious stones called agates that you can find on North Shore beaches today were formed in the amigules that took shape in Lake Superior's ancient lava flows.